Hello, Colonel Africa online students. Welcome to our fifth lesson in this topic of salts. In today's lesson, we're going to look at the preparation of salt by neutralization reaction. In this case, you're going to look at a case study whereby you're going to look at how sodium chloride is prepared by the neutralization reaction. We're also going to look at how we prepare red nitrate in the lab from red carbonate. It's also a neutralization reaction. Let's look at the procedure for the experiment 4.6, whereby it is the procedure for the preparation of sodium chloride in the lab. Measure about 25 centimeters cubed of dilute hydrochloric acid and pour it in a beaker. Dip universal indicator paper into the beaker. Record the pH. Measure 25 centimeters cubed of dilute sodium hydroxide solution and pour it in another beaker. Add 2 to 3 drops of phenolphthalein indicator into the sodium chloride, into the sodium hydroxide solution. Pour hydrochloric acid slowly into the beaker containing sodium hydroxide until the pink color just disappears. Test the resultant solution with universal indicator paper. Pour about 25 centimeters cubed of the resultant solution into a clean evaporating basin. Evaporate the solution until it is saturated. Allow the saturated solution to cool for crystals to form. When you're cooling medium, you have to cool it slowly so that you can be able to get large crystals of sodium chloride. Let's look at the discussion. The pH of sodium hydroxide is about 13, while that of hydrochloric acid is about 2. So, if you look at the pH scale, it starts from 0 to 14. That means the pH for sodium hydroxide is very high at about pH of 14. That of hydrochloric acid, which is amino acid, is very low at around 2. And when hydrochloric acid is added to sodium hydroxide solution and the resulting solution is tested using universal indicator, it is found that the pH is about 7. The 7 is on the middle, which means it's neutral. It's neither base, neither acid. This shows that the solution formed is neutral. The neutral solution contains a salt and water only. So a solution of water and salt only is neutral. A reaction in which a salt and water is formed is referred to as neutralization reaction. So in this process, in order to obtain sodium chloride, you're using neutralization reaction, whereby in this case we are neutralizing the alkaline, that is sodium hydroxide, using hydrochloric acid, and our end results are salt and water. This is the equation involved. Sodium hydroxide solution, it is in aqueous form, plus HCl, the acid, to get us sodium chloride, which is a salt, and water. And this solution, this product, is neutral. Phenolphthalein indicator is pink in alkaline solution and colorless in acidic solution. It is used in the reaction to determine when the reaction is over. Remember, in this case, you're neutralizing the sodium hydroxide solution using HCl. That means our initial solution is pink, so you're going to add HCl until the pink color just disappears, and that gives us the end point. It is used in the reaction to determine when the reaction is over, the point at which enough of acid has been added to exactly neutralize the alkali. This point is called the end point and is normally indicated by a color change. That color change from pink to colorless. Universal indicator paper shows a range of colors in alkaline and acidic solution. It is normally blue in bases such as sodium hydroxide, or alkaline such as sodium hydroxide, and red in acids such as hydrochloric acid. Universal indicators, therefore, they cannot be, or they are not suitable for determining the endpoint of an acid-base reaction or the neutralization reaction. In this experiment, phenolphthalein is normally used to determine the neutralization point, that is the endpoint, between the acid and the base. The other indicators that can be used, such as methyl blue, potassium nitrate, ammonium chloride, ammonium nitrate, ammonium sulfate, sodium sulfate, are prepared by the same method or similar method. This is the reaction or the preparation of potassium nitrate. You neutralize potassium hydroxide using nitric acid. In this case, we are preparing ammonium chloride from the neutralization of ammonium hydroxide or ammonia liquid using HCl, hydrochloric acid. Then sodium hydroxide is neutralized by sulfuric acid to give us sodium sulfate plus H2O. Neutralization is the action of acid on soluble bases to produce a salt and water, which is another method which is used to prepare soluble salts. Then let's look at how you prepare lead nitrate in the lab through the action of or from lead 2 carbonate. So you're going to find that the lead 2 carbonate neutralizes the nitric acid to give us lead nitrate. Measure about 25 centimeters cubed of dilute nitric 5 acid and pour it into a glass beaker. Warm the acid in the beaker gently. Add lead 2 carbonate to the warm acid a little at a time and stir. Continue adding the carbonate while stirring until effervescence stops. This effervescence comes from the production of a gas, and in this case it is carbon dioxide. Stop warming and filter off the unreacted carbonate. Evaporate the filtrate to saturation and allow it to form crystals. The warming is done in order to increase the rate of reaction or the rate of neutralization. And let's look at the discussion. When lead 2 carbonate is added to warm nitric 5 acid, there is an immediate effervescence, and this effervescence is due to the production of carbon dioxide. Warming speeds up the rate of the reaction because high temperature increases the rate of correlation between the reactant molecules, hence increasing the rate of reaction. Effervescence is due to the production of carbon dioxide gas. The reaction is complete when there is not more effervescence, which means that all the acid has been neutralized or has been used or has been consumed, and the unreacted lead 2 carbonate remains because it is in excess, and we normally use it in excess to ensure all the acid has been reacted. The excess carbonate is used to ensure that all acid react completely. This is the reaction. So I'm going to look at the chemical reaction or the chemical equation. So we have lead carbonate plus nitric acid to give us lead nitrate plus carbon dioxide plus H2O. So you can test this gas by bubbling it in calcium hydroxide solution. If you bubble it in calcium hydroxide solution, you form a white precipitate. It's the only gas that gives a white precipitate with calcium hydroxide, and it's because of the formation of calcium carbonate, which is an insoluble salt. Then other salts prepared by action of acid on carbonates include the zinc nitrate. It is prepared from zinc carbonate. You react the zinc carbonate with nitric acid, or neutralize it. You neutralize nitric acid using zinc carbonate to get zinc nitrate, carbon dioxide, and water. Calcium carbonate, if you neutralize hydrochloric acid using calcium carbonate, you get a calcium chloride, carbon dioxide, and water. That's how you obtain calcium chloride salt. Then ammonium sulfate solution, or the ammonium sulfate salt, is obtained by the action of ammonium carbonate on sulfuric acid, and you get the ammonium sulfate, carbon dioxide, and water. Then sodium carbonate plus nitric acid, you get sodium nitrate, carbon 4 oxide, and H2O. The reaction of the acids with carbonate is another suitable method for preparing soluble salt, as we have seen. And that brings us to the end of our fifth lesson. So you have the questions of the assignment 5, which is dealing with the preparation of sodium chloride and also the preparation of rain nitrate and also other salts that we have covered in that topic. So make sure that you do all the questions. Use the word document accompanying this video to check or to mark for this assignment after you do the assignment. Don't copy. Integrity is paramount. So we meet next time to look into lesson 6. So have a good one and bye.